Right. Okay. So today, so we should finish lecture 4 content, and then, if possible, I want to go to the next set of slides. Lecture 5 slides. Right. Last Wednesday, we started discussing operators, and then we discussed arithmetic operators, and then increment and decrement operator. So we briefly discussed that on Friday practical session. So I will share those videos today. Right. Today I will share those videos, and then you can check if you have missed them. Right. Right. So, like if I just remind what an operator is, right? So operator is it's a symbol that we use to do or use to say or use to tell or instruct to the processor to perform on our data. So it is a symbol that we used in our program just to tell the, maybe just say compile, just to tell the compiler to perform a specific operation. So here it says like specific mathematical or logical functions. The functions don't get it confused with the functions in C. In C, we learn functions separately, right? So we are going to talk about that within a few weeks, right? So the function means some operation, like some task, right? So it would be mathematical or logical operations, right? On data. data වලට මොන හරි දෙයක් කරන්න කියලා කියන්න දැන් තියෙන මේ සිම්බල් සෙට්. ඒ සිම්බල් එක දැක්කහම කම්පයිල් එක දානවා මේ මොකක්ද කරන්න ඕනේ. මේ මොකක් කරන්නද කියන්න කියලා දානවා. Right. So arithmetic, so these are the categories of operators we have. So we discussed arithmetic operators. In arithmetic operators, and so we have mathematical operations, mainly simple mathematical operations: addition, subtraction, multiplication, division. So modulus and division and modulus, they are modulus is also known as remainder, right? Remainder operator, modulus operator. So these are like connected, right? The division and modulus, those are very connected. Like the results would be different, but they are very, very close. And then increment and decrement. Even in increment, we have post increment and pre-increment. Decrement, we have pre-increment and post-decrement. Right. Based on where we put this operator, if it is before the operand, so it will be called pre. If it is if it is after the operand, so we call it post. So there's a request. Can you put past papers into the LMS? Yes, I can do that. Right. Right. So let's go to the next set of operators. Right. So these are arithmetic operators. So most of them are binary, but we have unary operators, increment and decrement. Right. Unary. That means just one operand is enough to perform the operation. Okay. So we did some interesting exercises using post and pre-increment operator on Friday. Right? So then, like I have given a very simple program, so you can guess the outputs of each printf. Each printf statement. So usually like here, addition. So we have two variables A and B. So we can add them, right? Addition, subtraction, and so on. I'm not going to discuss this. So you can type this program and you can check the output, or even without typing, you can first guess the output and then later on you can write the program and check whether it's correct. Right. Let's go to the relational operators. Okay. Right. So relational operators are all binary operators. Right. Relational operators are all binary operators. What does that mean? Again, anyone? I said the relational operators are binary operators. What does that mean? True and false. No, that's not binary. That's not what I meant by the binary operators. 1, 0. No, that's not what I mean. Yeah, good. Need two operands. They need two variables. Right. So even I said that they want two variables, yeah. But the correct correct way to say that is need two operands. Variables, anyway, not two variables, but operands. Need two operands. Operations are performed on operands. Right. So need two operands. Okay. Relational operators are binary, right? Remember that. Okay, so let's see what relational operators are. Relational operators are utilized when comparing two values, variables or constants. Okay. Relational operators, they compare to the, if we compare, definitely we need two operands, right? So suppose if there's just if there is just one girl in your batch, right? If there's just one girl in your batch, so then the boys, they cannot compare that girl, right? Like, so then that girl is the most beautiful, most intelligent, most most of, I mean, everything are like that. That's the best girl in the batch, right? So then, but you cannot compare, right? So then if you have two girls, then you can compare. So some boys would say, I'm කැමති මේ ගෑනු ළමයි දෙන්නගේ අරත් තමයි කැමති. එන්න මම එයාට පොඩ්ඩක් try කරමු. ඊට පස්සේ තව කෙනෙක් කියන්න පුළුවන් no. Uh, for me, she's the a beautiful one, and so I'm going to. So now, like you have many girls, right? Like the number of girls, so you don't have any problems, right? Like so. Yes. So this is compare. So we compare, right? So if we compare, right? If we compare two things, what would be the output? What would be the output? Right. So forget about these relational operators. If you compare in real life, if you compare something, right? So for example, like the same example that I have taken, like if you are comparing a girl, right? ඒ ගෑනු ළමයා ප්‍රීතිසනොන් වගේද? එහෙමනේ compare කරන්නේ. Right. ඊට පස්සේ දැන් ගෑනු ළමයි පැත්තෙන් ගත්තොත් මේ අර පිරිමි ළමයා චාමික කරුණාරත්න වගේද? Right? So in that comparison, you will get yes or no, right? So now I can understand. Like previously, I asked these operators are I told binary. Then I asked why they are called binary. Some of you answered like true or false, one or zero, right? Yes, like I can understand. Like you try to explain this thing, right? Yeah, right. So now you are correct, right? Now you are correct. So the output of relational operators are always true or false. Are these two things are equal? Is this one bigger than this? So there, definitely the results would be true or false. Right. So they would result binary value, true or false, depending on the operands. Sometimes it could be true, sometimes it could be false. But in C language, we don't have true or false values. Right? True or false values. We call them Boolean values. Right? Since there is no Boolean values in C, result is either 1 or 0. 1 or 0. So relational operators are binary operators. Their outputs are Boolean or binary in that sense. Okay, output take a binary. Even relational operators are binary operators because there are two operands are always needed. Right? Relational operators. So relational operators, how many? Yeah, okay. Right, so these are the relational operators that we commonly use. Equal. So we check the equality. If A equals B, it will result, if A and B are equal, the result would be 1. If A and B are not equal, so then result would be 0. In this example, A is 10, B is 20, the result would be 0. Right? So they're not equal. That's the opposite, right? If two things are not equal, then it will provide 1. If two things are equal, it will provide 0. Not equal na tamai එක. In this case, A is 10, B is 20. So the result would be, what would be the result? Right? In this particular example, what would be the result? It would be 1, yes, because these are not equal. Right? Yeah. So let's let's say we have two variables, int A, int B. Right. Let's say A equals B. So this should result, in this case, this should result zero. Is kept down 0 because they are not equal. They are equal. They are equal. Would be 1. Let's say not equal. Not equal. Now it is 0. If A and B are not equal, then it will output true or 1. අසමාන වුණොත් තමයි මේකේ true එක. True කියලා කියන්නේ 1. True is 1. See? Right. So likewise, we can discuss the rest of the operators. So not equal, greater than. Checks if the value of the left operand is greater than the value of the right. Here, in this example, A has to be greater than B to output 1. Right? To be true, A has to be greater than B. Less than, right? A has to be less than B. To be true, A has to be less than B. The opposite. And then greater than or equal. Greater than and then equality is added. So, for example, like I told you earlier, you have to get 2.0 or above, right? That means greater than or equal. So your GPA, right? Let's say your GPA has to be greater than or equal. Definitely, it has to be greater than 2.0. But you have to add the equality. Greater than or equal. Don't use like this. Huh? We don't have this kind of symbol in generally in computing. In maths, yes, we have, but in computing, we don't have. So instead, we use this. Greater than or equal, less than or equal. Less than or equal. Right, like this. These are relational operators. Remember, equal means two equal marks. Right. If it is just one, it is an assignment. Right, remember that. Equal operator is always two equal signs. Right, any questions? Any questions? Right. So these are actually simple. So there's a program. Please check this program and check the output. I'm not going to do all those things here, but I just wanted to show you first two. Then you can try the rest. Relational operators. Right. So next category, logical operators. So there's a question, can we use equal or, right, like instead of using is greater than or less than sign first, if you move this to the front, right? So then it is not greater than or equal, greater than or equal, right? Like you ask instead of using greater than or equal, like this, right? Definitely it will give an error. See, or the other way, yeah. So give compile error. See, with red color, you can see like it will show the error, and then down here, like in build messages tab, so the errors will be displayed. You can see the file, right? This file, you can see the line 12, line 12. So these are line numbers, line 12. Right. So then the message would be displayed. Error expected expression before plus. There should be an expression here, not equals. It's not possible. Okay. Right. Logical operators. Again, logical operators are similar to relational operators. However, the logical operators are like in logics, in Boolean logic, right? So we have three operations: and, or, and not. Right. The logical operators always result binary value. So that's why I told you it is similar to relational operators. The results are binary values, and then these logical operators are binary operators. Two operands are necessary. Sorry. Here, sorry. Only for these two. Unary operators are also there. Unary operator is also there. Right. So that's where this is sorry, because not is there, not is there. Right. So in so Boolean logic, have you learned Boolean logic in A levels or in any of the previous levels? Boolean logic. Yeah, and or not. Have you done? For maths, for physics, or whatever, you don't have physics, right? Like science for technology or in engineering technology. Do you have these concepts? Where did you learn Jana? Jana? Where did you learn it? In ICT. That's better. So in and or not. So these are we call Boolean logic. So these are the main Boolean operations. Right? And means right. So these are done on bits. In university mathematics, yeah. So that's what I wanted to ask, like in maths or physics in university. Have you done that? Okay, right, good, right. Even right. So these are usually like and means, right? If I create and table, right? Let's say we have A, B. A and B, right? in our C language, we use two ampersands represent and, right? So if then 0 should be a 0, 0, 1. So usually, like when we create that, right? So if both operands are 0 and is 0, it's just first let's say like and, right? And කියලා අපි ටිකක් මුලින්ම ගමු. And කියන එක දැම්මහම if both are 1, then only it is 1. In all the other cases, at least 1 is 0, or at least 1 is false, the results would be false. දෙකම එක නම් විතරයි එක. So this is called and. In our program, we represent it with ampersand, double ampersand. So this is the ampersand sign. Right, we make many Indian. A and B. Right. So this is how we write it in programs, in C programs. Similarly, we can find O. A O is given or represented in programs like this. O. O is like O operation is true where O operation is false. Let's start from there. O operation is false only when both operands are false. This one or this one. So the idea is if I say it in a sentence like if A O B is true, A O B is true, then result is true. If A or B is true, right? Like, so if you ask someone, suppose if you have two friends with you, right? So you say like, I want to buy Kottu. So if you at least one of you have money, give me. So දෙන්නෙක් ඉන්නවා දෙන්නගේ කාගාව හරි සල්ලි දෙනවා මට දෙන්න මට මේ කොච්චර කාලේ ඉන්න සාමාන්‍ය එහෙම ඇහුවාම මේ යාළුවෝ නම් උඹට නිකන් ඔළුවට කනට දෙකක් දෙනවා මේ තනියම එහෙම කොත්තු කන්න දෙන්න පුතවත් දෙයක් කියලා මේ සාමාන්‍ය එහෙම වෙන්නේ මේ අපි හිතුව එහෙම ඉල්ලනවා කියලා දෙන්නගෙන් කවුරු හරි ළඟින් සල්ලි දෙනවා නම් මට දෙන්න. So then if you have two friends, the first friend got money, he'll give. The second one got money, he'll give. In either case, you will get, if both have money, one of them would give. That means, so one of you have raised your hands. Is it a mistake or is there a question? If you have a question, you can ask, right? Otherwise, I will continue. Okay. So here, one of you got money in that my example. One of your friends got money. You will get a quote, right? Only time when you don't get kottu, so that means both of your friends don't have money. Both are zero, then only this one is zero. In all the other cases, right? Let's say, like you ask your friends to go to eat kottu with you, right? එක්කෙනෙක් හරි එනවනම් යනවා කොත්තු කන්න. අන්න ඒකට කියනවා මේ ඔයාලා දෙන්නේ කවුරු හරි එනවනම් මම යනවා කොත්තු කන්න. බුදු කියන්නේ. ඒතර දෙන්නගේ කවුරු හරි එක්කෙනෙක් කිව්වොත් එහෙම කවුලක් නැහැ කොහොමද කොත්තු ගන්න හම්බ. දෙන්නම කොත්තු කන්න කැමති නම් ඒත් ප්‍රශ්නයක් නැහැ තුන් දෙනාම ගිහින් කොත්තු කන්න. හැබැයි මේ දෙන්නගේ එක්කෙනෙක්වත් කැමති නැත්නම් ඔයාලා තනියම යන්න කම්මැලි ඉන්නවා. Right? But in the first, this case and case, if both your friends are going, then only you are going. යාළුවෝ දෙන්නම කැමති නම් විතර එක්කෙනෙක් විතර කැමතිලා බෑ. අනිත් දෙන්නම කැමති වෙන්න ඕනේ. ඒතකොට තමයි කොට්ටුවක් ගන්න. Both of the friends are true, or both of the friends are true, so then that is also true. Right? Not easy, easier than that. Not and this is all. This is not easy, very easy, right? It is unary. Right? Let's say if, not. Right? If A is 1, not A is 0. A is 0, not A is 1. So when we write it, as summation mark in front of. Actually, I have a niece. niece. So my sister has a daughter. Like she's a perfect example of not kid. If we say don't go outside, then she will go outside. And then we will go outside, and then if we say we are all outside, and then if we say don't go inside, then she will go inside. Like she's a uh, not gate actually, right? Not operator. So that's a not, right? So these are the, so remember double ampersand is and. Logical operators not double. Right now, so let me show you. Right now, if I have A and B, right, let's say ampersand, how it end, right? So here I put ampersand. I can put spaces if you want. It would work, right? Even without spaces, it would work. Right. A and B. Right. Can anyone tell me what would be the result here? What would be the result? Right. So in this table, so I gave you like if A is 0, B is 0, A and B is 0. Like, but here no zeros or 1. A is 10, B is 20. So what would be the result here? Can anyone guess? One say 0, right? And then one say 8. Most of the people say 0. One say 0, and then there's another 1. Yeah, some people say 1, some people say 0. Right, let's say what is the answer? 1. Why is that? Why is that? Why it is 1? According to our table, so from and operate, from logical and, so we call it logical and. It's a logical and we can get 1 only in one situation. What is that? If A is 1, if B is 1. If both are 1, we can get 1. Right? right? So here, none of them are 1. So why the answer is 1? Like now, these are wrong answers. 1 is the correct answer. Why it is 1? Anyone? Can anyone guess? Let's go to the note. I think there. See, this one answer. 10 and 20 is not equal. No, no, that's not the reason. 10 and 20 is not equal. No. Reason is this. Here, in the description, you can see if both operands are non-zero, then the condition becomes true. And true means 1. If both are non-zero, if A and B both are non-zero, A and B logical operation would result 1. So if you change any values, right, like, right, whatever the values, if they are non-zero, then this would be 1. Right? But if one of these values are 0, then the result would be 0. Zero the නැද්ද කියලා විතරයි check කරන්න. So let's say I don't know whether this would work, right? Let's say let's say this one is right. See, this is 0 again because A is non-zero, but I have given null character. Null character. This is null character. This is sorry, null. So null character, the meaning of null character is actually we don't call 0, but it is, this is not non-zero. Non-zero එකක් නෙවෙයි null කියලා කියන්නේ. එතන දැන් බිඳුව දැම්මත් හරි. එහෙම නැත්නම් null character එකක් කියලා කියමු. ඒකේ meaning එක මේ මොකුත් නැහැ කියන එක. Right. It is again considered as like 0. 0 category එකේ එකක් තමයි. So if any of the values are 0, so then it is 0. If both are 0, definitely it is 0. we check whether both are non-zero. And we can check, right? So this is used, like this is the ampersand. This and logical and operator is used to check whether both are true. Right? Both are true. Remember, this ampersand is used when I'll show you, like in when we use conditional statements. If else statements, we frequently use ampersand. Right? That we double ampersand. Remember that. Very important. Double ampersand. Right? Or logical or if any of the two operand is non-zero. Deking එකක් හරි zero නොවන එකක්, the result would be 1. If any of the two operand is non-zero, then the condition becomes true and the result would be 1. Third one is very easy. It is unary operator. Unary, just one operand is enough, right? And then it will reverse, right? We say like let's say B, right? Let's say A is 20, B is 10, right? Not B is, so let's say, yeah. What would be the result here? Can you guess? Most of them you are saying 0. 0, 0, yes. So let's see. Yes. It's 0. Reason is, right? B is, if B is non-zero, right? Any value other than 0 would consider as 1. So B is 1. Not B is opposite. So, so this one B, B. The result will be same, right? Not B. See, B is 10. It is non-zero. That means B is considered as 1. Not B. It is 0. Suppose B is 0, then the result will be 1. But mostly we use, we don't use this much with the numbers, right? We use that especially when conditional statements, right? We use that a lot, right? So logical operators. Remember logical operators, 3. We use double ampersand to double O or not. So true or false, like in this operation, like any value which is non-zero is considered as true. In this case, P is zero, that means it is false. A is true because it is non-zero, it's 20. So A is considered as true when it comes to logical, right? Right, any questions? Any questions? Right. There are no questions, so we are not going to do this. So please take that. Right. Check the outputs. Then bitwise operators. These are another very uh, confusing set of operators. Right. So bitwise and then assignment operators. Then MISC operators, those are not very difficult. So this bitwise operators. These are rare actually, right? Like, I mean, in our general programming, so we don't use them much. However, those are used in some cases, especially in like system related programming, using C language. So these operators are used, right? Bitwise operators. So bitwise operators work on bits and perform bit by bit operations. Right? So again, the truth table, right? The table that I have shown you, so we call them truth tables. True or false, this information can be gained from that. So the general bitwise operator, general truth table is this, right? So the bitwise operators are the names are the same. We have and or not for the complement, right? However, in bitwise operators, we use just ampersand, one ampersand. Or so we use just one. Let's see what are those bitwise operators, right? Like we have bitwise and bitwise O, and then bitwise. So this is special. This is called bitwise XO. Right. So here there's one special verb, copies. Copies a bit to the result if it exists in both operators. So that means the idea here is copies a bit. That means it is true. So the meaning of this is it is true if there both operands are what? Or both operands are true. Then only copy is a bit to the result. That means the result is 1. Copy bitwise O copies a bit if it exists in either operand. Right. දෙකෙන් එකක හරි තියෙනවා නම් true. But bitwise, forget about bitwise, just XO copies the bit if it is set in the operand but not both. In one operand but not both. Right. I forget about XO. So exclusive O. AB 0, 0, 1, 1. XO means it is true. Sorry. If it's set in one operand but not both. In this case, it will be 0, 1. It is O, similar to O, but XO. Difference is here. Right. So this is the XO, right? So now let's see what these bitwise, why they are called bitwise. Right. And then we have shift operators as well. Right. So these bitwise operators are performed on bits, right? Like if we have two, let's say two values, let's say 8 and 5. If you use bitwise and bitwise and bitwise and then what we do is we convert this into binary. And do the operations on that. I mean, we don't have to convert them into binary separate because actually internally those are represented in binary. So we get that binary value. Right. We get those binary values and perform AND. Right. So I think I have, yeah, bitwise operators. Suppose we have 60 A, 60 B, 30. In binary format, they will be as A and B. Right. So then A and B, remember there's one ampersand. One ampersand. So if you perform AND operate on this, so bitwise AND would be calculated. Here 0, 1, 0, 0, 0, 0, 1, 1, 1, 1, 1, 1, 1, 1. Over the other two, all the other like 4 bits, results would be all 0. So these are called bitwise operations. Right? The operations are done in a bitwise manner. So what is the number represented by this binary value? Sorry. Right. So 60, 12. So let's say 60 and 30. I have a program, so I can easily do that. So if I use a bitwise and this is bitwise and so let's say the answer is 12. Right. Answer is 12. Why is that? Bit in a bitwise, in bit level, if we use and operator in bit level, so the result would be this 12. Right. If you use O operator, what would be the output? So here operator 0, 1, 1, at least 1 is 1, the result would be 1. So in this case 0, 1, 1, 1, 1. This one would be the result. The answer would be 61. You can check whether this one is 60. And then XO can be applied right only like if at least one, if only one operand is 1, then only the result will be 1. Right. If both are 0, definitely 0. Both are 1, 0. Both are 1, 0. If one of these bits are 1, then the result will be 1. එකක් විතරක් එක නම් විතරයි එක වෙන්නේ. දෙකම එක හරි දෙකම බිංදුව හරි වුණොත් බිංදුව. Right. This is X. And then this one, the final one, would be to represent so then the next one Okay, so we have another 15 minutes or so. I'm not taking 15 minutes, like maybe within maybe 10 minutes. I will finish this one. So this one, right? Complement. Bitwise complement, right? So it will give right binary ones complement operator is unary and has the effect of flipping bit, right? So it will give so since you have done your A levels already, like so you know two's complement. Two's complement. I'm not going to explain two's complement now. In two's complement, basically what we do is, so if we have set of bits, right? We reverse, right? If it is 1, we make it 0. If it is 0, we make it 1. Reverse and we add 1. That's the two's complement, right? So here, I say, so this is the symbol that we use to make it like bitwise complement. Let's see. The answer is 40 minus 40. Why is that? I'm not going to explain why it is 14 in the practical session, so we can discuss those bitwise. Right, bitwise complement. Right, so I'll keep that to you to analyze and think about, and on Friday, so we can just check whether you have found the answer, you have whether your assumptions are true. Right. So bitwise complements, what we basically do is we flip the bits. Right. Bits mark කරනවා ඊට පස්සේ ඇත්තටම නම් ඒක two's complement පාවිච්චි කරනවා minus අවස්ථාවේදී. Right. Right. So then we have another two bitwise shift operators. Bitwise left shift and bitwise right shift. Right. So in this case, actually, what we do is, if we have a number like any value, right, we can shift the bits of that value left or right, right? So it is, the idea is very simple, right? So let's say we have 1 1 0 0. Right. So let's divide this into, let's say like 1 1, like this is the number. Right. We can shift this number, shift these bits 1 or 2 or 3 or any number of, if we shift ones, right? So then the result would be, right, 1, 0, 0, 1, 1. This would be shift 1. So this one would come here, this one would come here, this 0 would come here, this 0 would come here. And this one would come here, and this one would come here, and it will be ignored. If this is a, like, let's say this is a like cliff, right? Mountain, right? So then this one would fell down. So then when we push this one by one, the last one would be fallen down. Right. This is just one. So this is called right shift. Right shift. Right. Right shift. Right shift. A is right shifted by 2. The right shift. You know. So this is the other way around, left shift. So if we have, let's say, the other way, not this way, but this way. So in that case, right, these slightly change. This one would come here. Right, okay. So now this one would come here. This one would come here. This one would come here. So like 1, 1, 0, 0, 1. Right, okay. 1, 1, 0, 0, 1, 1. Right. So then there's a one vacant slot. So then we would add a 0. By default, 0 would be added. This is called left shift. Right? So if I, let's say, okay, right, let's say A 2. A is right shifted by 2. Let's see the answer. 15. A 60. Write it in binary and shift it by 2 and check what the result. Check what the result is. So I am just keeping it for you. Right? I'm not going to explain it. So we can do some exercises on Friday, right? So those are bitwise, right? And then we have assignment. Usually assignment of a simple assignment operator. So you know, right? So we can assign a value to a variable. We can assign a value to a variable. Remember again, just one equal sign is assignment, right? But logic relational operator equal is two equal signs. Right? Remember that. This is assignment operator. Right now, so with assignment operator, we can use other arithmetic operations or bitwise operations. Or yeah, it's a bitwise operations. Right. So here, I'll just give you one example here. And equal. So this one means add and assign. Right? If we say like a plus equal 10. This means we have a, right? Add 10 to a and assign it back to a. Right? So here a plus 10. So this means a is assigned with a addition 10. Right. So if we have variable a, right? A variable, suppose we have a value here. Let's say 20. Right. It says take that value. This is a. This is a. Take this value 20 and then add it to 10. Now the result would be 30. Right. Assign it to a. Right now, this value would be assigned here by negating this. Very, very simple, very simple. Right? So all the other assignment operators are the same. Right? The value is assigned to the leftover. Final value would be assigned here. Assign and add an assignment, subtract an assignment, multiply an assignment. So you left shift and assign. Right? So if you use this, right? A would be left shifted by 2 and assign it back to A. The result would be assigned to A. Right, okay. So now it's almost the time. So that's then just look at this one. And so we are going to talk about this in our later lessons, right? When we talk about pointers and then conditional expressions, right? Right. Then we have something called operation, precedence, and associativity. Precedence and associativity. So in the practical session, so we can discuss with some practicals what it is and how. So then Friday, so we can finish these operations and data representations and operations together, right? Right. So that's all. So if you have questions, you can ask. So otherwise, see you on Friday. Have a nice week. Until then. Right. Thank you. If you have questions, you can shoot. So if you need the whiteboard, yeah. So, okay. So if you need to check this, how to be this. Right, okay. Okay, so thank you very much. See you on Friday.
Thank you, sir.